Welcome to Wednesday. Today's our last Eureka Math lesson of the week, and we're going to do another lesson on triangles. Yesterday we learned about classifying triangles, which meant that we sorted them into different categories based on their side lengths and their angles. Our I can statement of today says this: I can construct triangles by given criteria. So today what we're going to do is make triangles. I'm going to give you the criteria, and you are going to use what you know about the definitions of the criteria I give you to create triangles. Now, what do I mean by criteria? Well, what I mean is I'm going to tell you to create triangles that have a certain kind of side length and a certain kind of angle. Remember that all triangles have two names. Usually, we see the side length name first and then the angle type. But today we're going to see an angle name first and then the side length. It really doesn't matter. I know that if somebody writes my name down as Sarah Isley, that's me. Or if they write it down as Isley, Sarah, that's still me. So it doesn't really matter if the triangle's name starts with a side length criteria or an angle criteria. So today I'll be choosing one side length and one angle, and you're going to be putting that together to create a triangle. Now, let's go back and let's review some of the different types of triangles. So we know that we can classify triangles by their side length. Equilateral triangles have 3 equal sides. Isosceles triangles have 2 equal sides. And the way that I helped you remember that was to think about your 2 eyes. That sort of reminds me of the word isosceles. I think about eyes. And I think I have 2 eyes, so an isosceles triangle has 2 equal sides. And then last, scalene triangles have no equal sides. And classifying triangles by their angles a little bit easier because we've been working on angle types. And an acute triangle has 3 acute angles. All are the same. In fact, they're exactly 60 degrees. Because inside of a triangle, you have 180 degrees. If you added up all the angles in any triangle, you would get 180 degrees. And I'll show you why in just a second. So if I have 180 degrees, and each of these is 60 times 3 is 180. So an acute triangle has all acute angles. An obtuse triangle has one angle that is obtuse or greater than 90 degrees. And a right triangle has one angle that is right or exactly 90 degrees. Well, let's make a few triangles by side length. And the way I'm going to do this is I raided my pantry, and you're welcome to do this too. This is just kind of a fun way to play with your food and make triangles. But one of the things that I did was I got some pretzels. I love pretzels. And I love these little stick pretzels because they're exactly the same length. Now, you could use veggie straws if you wanted to. So I'm actually going to make 3 different types of triangles. And by the way, guys, if we were at school, we would be doing this. Bummer. I know. Oh, well. That's all right. We're going to do it right here, right now. So we're going to make 3 different types of triangles. So I'm going to get out 9 pretzel sticks. You can do this with me. And the first one that I'm going to make is my equilateral triangle. Remember, my equilateral triangle has 3 equal sides. So here is my equilateral triangle. Really easy way to turn an equilateral triangle into an isosceles triangle. It's just to start snacking. I really don't usually eat like that. I bit off a little bit of my triangle, of my pretzel here. And you can see, look at that. 2 that are the same length. 1 that is the oddball, a little bit shorter. Okay, there we go. And I've created an isosceles triangle. These side lengths are the same, and this one is different. Just like here, all 3 were the same. That's why I make those 3 little marks. This one is different, so I'm going to give it a different mark. And then last but not least, I'm gonna make my scalene. I'm gonna make it over here because I am running out of room. I hope you're doing this with me. I'll show you another way to do it in a second. All right, this time on my scalene, I have to have none that are the same. So I'll keep you like this. I'll just maybe, ooh, a lot of crumbs there. Make you about like that. And make you like that. Okay, 3 different lengths, and I can put them together any way I want. There's my scalene triangle. I could have done it like that. There we go. All right, my scalene triangle has no sides the same, so I'm going to mark each of them with a different set of tick marks, just like that. There you have it. You can snack and do math. Now, if you don't have pretzels at home, there's other things that you can use to make the same kind of thing. So I'm going to move my pretzels, and we're really quickly, I'm going to flip this over on the back so we have a nice clean place to start. I'm going to get out fettuccine. Love some Italian food. Really missing going to Luigi's right now, but that's okay. They have takeout. So I'm going to get 3 pieces of fettuccine, or spaghetti works. It doesn't matter. But I bet you have pretzels or veggie straws or spaghetti or something in your pantry that you can use to do this with. So I've got 3 identical pieces of fettuccine, and I am first going to make, you guessed it, my equilateral triangle. There we go. 3 equal sides. Now I'm going to change it just a smidge, and I'm going to make my equilateral triangle into an isosceles triangle. I'm going to do that by breaking one of my pieces and making it smaller. Ta-da! There we go. Isosceles triangle. And then I'm going to make my scalene triangle. So remember, I have to have 3 sides that are all different lengths. So it's good to kind of compare them while you're breaking. There we go. 3 sides, 3 different lengths. And I'm going to put them together to make my scalene triangle. There we go. Very cool. So you can even use stuff around your house to create or construct triangles. This isn't in Eureka Math. This is just in Miss Isley's head. I think it's really fun. So go play with your food when this is over, and tell your mom and dad that I said it was okay. But let's keep going, because we actually today have to create some triangles that include both the side lengths and the angle measurements. So what we're going to do first is we are going to use some specific criteria to create or construct triangles. So we're going to practice a couple of these. The first one that we're going to create is going to be a right scalene triangle. And we're also going to construct an obtuse isosceles triangle. Now what you need for this activity is some grid paper. You can rip the paper out of your journal if you want to. If you don't have grid paper at your house, there's a link on Canvas today where you can print some out. And another couple of things I'm going to have close by are a pencil. I'm going to have 3 different colored pencils so I can label my sides, but you don't have to have that. You can use those little marks to do the same thing. I'm going to have my grid paper, and I'm going to have a straight edge as well. It doesn't have to be a ruler. And the other thing I'm going to have is my right angle template, just to have. I'm also going to show you how to use this right angle template as a ruler if you don't have one. I would have been doing this if we were getting ready for the EOG right now. Okay, so I have to create some triangles out of given criteria. That means I have to create a triangle that is a right scalene. That means it has to have 1 right angle, and it has to have 3 sides of completely different lengths. So the first thing I'm going to do is create my right angle, which is really easy to do on graph paper because every single one of these little grids where they come together forms a right angle. So I can go ahead and I can create my right angle. I want you to do that too. And the next thing I have to do is I have to draw the lengths of my triangle and just make sure that they're all different. So I think what I'll do is I will use these units to help me measure. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I think I'm going to go out 8 units. And it helps if you have your straight edge, but if you don't, just try to draw as neatly as you can. Okay, so this side length was 8 units, so I think I'll make this side unit 1, 2, 3, 4 units, just like that. And then I'm going to connect with my straight edge these two. Now, on first glance, these two sides look awfully close. So if I want to check them, and in geometry, precision matters, what I'm going to do is I'm going to make myself a handy dandy little ruler. I'm going to line up the end of my paper, the edge of one side of my triangle, and I'm just going to put a little mark here. And then I'm going to see, ooh, are these the same? No, they are not. You see that, guys? The little mark was right here where I measured my top line segment, and I can see that the bottom one is different. So I know that this is a right scalene triangle. Now I'm going to finish by giving it my specific geometric little, I guess, marks to show. So this is a right scalene, so I'm going to put my right angle square in the corner. And then I'm going to show that each of these sides is different. You know, I don't even need to worry about those colored pens because I can make the marks 1 tally, 2 tallies, 3 tallies. That means that all 3 of these are different. So I've just created a right scalene triangle. The next triangle I want to make is an obtuse isosceles. Now, here I have to think, what am I making? I'm making a triangle that has one obtuse angle. That means it's going to be greater than 90 degrees. So this angle that I'm going to make that's going to be obtuse is going to have to look something like that. And I also am going to make it isosceles, which means that I have to have 2 sides that are the same. So that's going to be really important today. All right, so here's what I'm going to do. I'm going to create the bottom of my triangle just like this. And instead of making it a right angle, I know it's kind of got to go out like that to be obtuse. So I think what I'll do is I'll use the same little mark that I did right here, and I'm gonna make the bottom of this triangle extend to this mark. There's a lot you can do with grid paper and an extra piece of paper, and I would have shown you how to do this for your EOG. I want to make sure that this side of my triangle, because it's got to be isosceles, that means 2 sides have to be the same. So I just have to pick a measurement or length measurement for 2 of those sides. So this is how that little piece of paper helps me. If I make this side this length and this side the same length, I'm going to have an isosceles triangle. 2 sides, same length. Now the last thing I have to do is connect the 2 ends. I can keep using this paper if I want to, or I can grab my straight edge. It doesn't matter. Okay. And I've just created my obtuse isosceles triangle. Now I've got to go ahead and mark it. So I'm going to mark this arc and put an O for obtuse. Now if we were at school, we would be measuring this angle measurement to find out exactly what degree measurement it was, but it really doesn't matter here because it just says an obtuse isosceles triangle. So any obtuse angle is going to work, and I know I've got one. It's greater than 90 because 90 would be sticking up straight like that. All right, and it's isosceles, so I'm going to mark the sides that are the same with the same kind of mark, And I'm going to mark the ones that are the one that is different with 2 little dashes. So here I have my obtuse isosceles. This is so fun, isn't it? Okay, on to some more. Now these are the problems that are actually in your problem set for today. So I don't know about you, but I think it's easier to do this on graph paper rather than in the problem set. So if you'd like to continue with me, we're just going to keep working, and we're going to keep working using graph paper. So you might want to grab another piece of graph paper, and I've labeled them. This is problem number 1, and this is A, B, C, and D. So our very first triangle that we're going to create is a right isosceles. Now yours might look different from mine. You know why? Your right angle is going to be the same as mine, but your side lengths might be completely different from mine. It doesn't matter, but it's going to look about the same. So I'm going to make my right isosceles. This time I think I want to make my right angle going this way. But it's still a right angle. And this one's going to be really easy to make since I'm making a right triangle. That's isosceles. I need 2 sides that are the same length, so this is going to be really easy. I'm just going to count the same number of units to the side and down, and I'm going to have my isosceles triangle. I have a lot of crumbs under here from my pretzels, so let me get rid of those. Okay, I think I'm going to just make these 3 units. 1, 2, 3. This is going to be a little bitty triangle. And 1, 2, 3. Here we go. I'm going to use my straight edge to connect them. All right, here are my sides that are the same. This is the criteria for an isosceles triangle and my right angle. So this is a right isosceles triangle. Now you could have drawn it bigger. You could have made it, let's say 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 across. Maybe I'll even go 6 up and 6 across and connect them. And you can see that these 2 triangles look very similar. They're not exactly the same because they're not the same length in the sides, but they're both right isosceles triangles. So that's what I'm saying. It doesn't matter if your triangle is bigger or smaller than mine. They're going to look about the same if they are right isosceles. Our next one is obtuse scalene. This one is perhaps the coolest triangle to draw, and it might be one of the most challenging to draw because we've got to get that obtuse angle and make the side lengths different. So once again, I'm going to remember that I can't draw a right angle. I've got to make it go this way. So I am looking to make my side lengths different. So I think what I'm going to do is use the edge of my right angle measuring tool again. This is such a great tool to have. It's just a piece of paper. Index card works. And I think what I'm going to do is I'm just going to count out how many units I want to be on the bottom. I think I'll say 5. 1, 2, 3, 4, 5. And I've got to make this side a different length from this one. So let me go ahead and just kind of make myself a cool little measuring tool. It's hard for you guys to see, I know. Put that on there. So this side has to be different length from this one. So I'm going to make it a little bit longer, I think. I'm not making an isosceles, I'm making a scalene. So I've got to have sides that are different lengths. This one's definitely shorter. Then I'm going to connect my 2, and I can see that this side is definitely bigger than either one. I'm going to draw my obtuse arc, write an O, and I'm going to show all 3 sides are different. So I have followed the criteria again to make an obtuse scalene. Criteria meaning I don't get to just draw whatever kind of triangle I want. I have to make it specific based on these classifications. Alrighty, acute scalene. Another one that has all three sides different, but this time I'm making an acute angle. So this time I have to make an angle that is smaller than 90 degrees. All right. I'm going to make this one like that. Look at that. Definitely an acute angle. If it were all the way up here, it would be 90 degrees, but it is not. I've also got to make sure I make the side lengths different. So I think I'll go out about 7. 1, 2, 3, 4, 5, 6, 7. I'm going to use this tool to help me find an empty side here. Okay, I want to make sure that this side is bigger than this one or smaller. I think I'll just maybe make it go up to about right there. Don't want to make it the same, it can be smaller. Ooh, you know what though, if I do that, that might look like a scalene triangle. I mean an isosceles triangle. I don't want to make a isosceles triangle. Let's see, let me measure this side. Okay, this side is going to go to here. Okay, ooh, look at that. If I draw down here, I'm going to end up with an isosceles triangle. I want a scalene triangle, so I'm going to have to go out just a little bit more. Okay. This one's also tricky to draw. And let's see what happens. Now, okay. Let's just make sure these are not all the same side lengths. Okay, this side went from here to here. This side is shorter, and this side. All right, 3 different side lengths. That one's a tough one to draw too. And all of my angles are acute. Very cool. I almost drew an acute isosceles triangle just a second ago. So this shouldn't be too hard. So once again, I am going to draw a triangle that has 3 acute angles, but this time I need to make sure my side lengths are the same. So what I'm going to think about is think back to that pretzel one that I made. I think that might have been an acute isosceles triangle. Let me just take a look at that. Wow, that's a tall pretzel. All right, 2 sides that were the same, one that was different. I think I want to make my triangle look kind of like a teepee, kind of like that one. We're all pretty familiar with this shape, so I'm going to come down. I think I'm just going to use my same measuring tool. Let's see. Acute isosceles. I think I'll draw to about right here. Okay, and I'm going to draw this side, the same, and I'm going to connect them. These 2 sides are the same, and this side is different, and all of my angles are definitely less than 90 degrees. I can check them if I want to. Oh yeah, you're hiding. Oh yeah, you're hiding. Oh yeah, you're hiding. Okay, my acute isosceles triangle. Now I told you a few minutes ago that I was going to show you why triangles equal 180 degrees. And let me show you. I'm going to use my pretzels again. So take a look at my acute isosceles triangle that I made with pretzels. Okay, if I were to take my triangle and just lay it flat and take it apart, what would I have? I would have a straight line, wouldn't I? What's the angle measurement of a straight line? 180. I'm going to fold it back up everything inside my triangle. If I add up this angle plus this angle plus this angle, it would be 180, because when I stretch it out, I get a straight angle, 180 degrees. Now I know that this is a little bit tricky to follow along with, and if your triangles don't look exactly like mine, that's completely fine. I hope you've had fun practicing them, and your exit ticket today, you actually have to take a picture and submit it to me online, because there's really no way to draw them online. That would be a little bit tough. So today you're going to draw 2 triangles based on the specifications that you are given, the criteria that you're given, and then you are going to send me your pictures. But just remember, think about the type of angle you need, think about your side lengths. Use your graph paper, use your right angle measuring tool. If you've lost it, go grab an index card, fold a piece of paper, something. This works really well as your straight edge, as your ruler, and also as your right angle measuring tool. So I hope you've had fun with this today, creating with pasta, creating with pretzels, and creating on graph paper. See you next time.